Good morning all. I welcome you all for my next series of lecture on JK map conversions. So in the last video we have seen about our SR conversion. That is how your SR will be converted into other three types of flip-flops. Now in this part we will be seeing about how your JK. Okay, however JK flip-flop will be converted into other three types. Okay, which means that how here JK is converted into SR flip-flop or D flip-flop or T flip-flop. Okay. However, JK is converted into SR, D and T flip-flops. Okay. So first I will go with here JK flip-flop to SR flip-flop conversion. So already I told you your SR is your destination, JK is your source flip-flop. So for the destination flip-flop SR Qn plus 1, I am going to draw your extended truth table. Okay, I am going to draw your extended truth table. 0 0 either 0 or 1, then 0 1 either 0 or 1, and for 1 0 either 0 or 1, and for 1 1 either 0 or 1, and we know the condition, that is nothing but what 0 0 means a present state will be retained as such. For 0 1 it is 0, for 1 0 it is 1, for 1 1 it is a don't care condition because it is like an indeterminate form. Now I am going to extend this to here JK flip-flop. Okay, I am going to extend this to here JK flip-flop. For this we want to know the JK flip-flop excitation table. So JK flip-flop excitation table is what? Present state, next state, and what is your J and what is your K. So this is 0 0 0 1 and 1 0 and 1 1. Okay, so this can be written as 0 1 x x, and this will be x x 1 0. So this one keep it in the mind. So now we are extending this. So where you have here 0 0, it should be replaced with 0x. So this will be 0x, and 0 0 here also it will be 0x, and for 0 1 it should be replaced with 1x. For 0 1, so for 0 1 it should be replaced as 1x, 0 n this should be replaced as 1x, and for 1 0 it should be replaced as x1, and 0 it will be replaced as x1, and for 1 1 it should be replaced as x0, and it should be replaced as x0. So here also I am having 1 1, so this should be replaced as x0. So here if you see that 0x, so here it is a don't care condition, so we are not going to fit out about this. Okay, because already this came in here 0 1 condition, 0 1 or 0 0, already it is there 0 1 or 0 0. So 0 1, if I take this as 0 or 1, if it is on the 0 your term, if it is on the 0 it will be like you will have their output as 0x, and once again the same thing will get repeated. So we are not going to bother about the next two states. Okay, we are not going to bother about our next two states. So only we will be focusing on the first part of the terminals for here SR flip-flop. Okay, so now if you see it is going to get stopped at this point. Okay, so the next thing is what? I want to find the value for here J and K. I want to find the value for here J and K. So when you talk about the value for here j and k. So j, first I will go with your j term. So here it is going to depend on 3 variable function. Okay, yeah, 3 variable function. So this will be your jk, this will be your qn, can be either 0 0 0 1 1 1 and 1 0. This will be either 0 or 1. So where you got your output, I want to check it for your j. So I have your outputs in 4 locations. Okay, I have my output in 4 locations, that is 0 0 1. Okay, that is 0 0 1. So this is this is your yes and r. 0 0 1 0 0 1. So 0 0 1, the output is x. Next one is 0 1 1 0 1 1 0 1 1, output is on the x. The next one is 1 0 0 1 0 0, the output is 1. Then 1 0 1 1 0 1, the output is x. Okay, so when you see like this way, I have only one pair over here, and for this pair the answer is nothing but here s into r dash. So your j is nothing but s into r dash. Similarly, now you want to find for here k term. So once you want to write for here k term, once again okay, I am going to draw a 3 variable Karnaugh map. So this will be your SR, and this will be here on the QN 0 or 1. This will be 0 0 0 1 1 1 and 1 0. Here also I have 4 outputs. First one is 0 0 0, it is nothing but in the x. Then 0 1 0 0 1 0, that is also your in the x. And the next one 0 1 1, that is 0 1 1, that is your 1 condition, and 1 0 0 1 0 0, that is your x condition. So here if you map, you will get one more structure like this. This is nothing but s bar into r, s bar into r. Clear? S bar into r. So now I want to draw our SR. Now I want to convert here JK to SR. So JK to SR means what you will do? I will draw here JK flip-flop. So I want to draw my JK flip-flop. So this is J, this is K, and I will have one clock pulse, and here you will have your QN output. Here it will be QN bar output. So one of the input is S and another input is R. Okay, so what you will do is, one is on the S, another is on the R, and I will take a complement also here. This is for S and another is here R. Okay, so for here and the J it is K, it is S bar into R. Okay, and for here J it is S into R bar. So S into R bar. So this into this into this, which will be connected to an AND gate and OR, and S bar into OR. So S bar into OR. Okay, so now we have converted your SR flip-flop to JK flip-flop. SR flip-flop is now converted into JK flip-flop. Okay, so now we will go with the next conversion. Okay, that is JK flip-flop is converted into SR flip-flop. Now we will go into next conversion, which is nothing but JK flip-flop to D flip-flop. Okay, JK flip-flop to D flip-flop. So here also the first thing is what? For the D flip-flop, I want to draw my extended truth table, and for my JK flip-flop, I want to draw my excitation table, and for the source flip-flop, that is for your J and K, you want to go with your K-map reduction, and finally a logic diagram. Okay, so logic, these are the steps you want to follow it. So JK flip-flop, we want to draw your excitation table. So JK flip-flop, now excitation table I am going to draw Qn plus 1. So where you have your input as J and K, 0 0 0 1 1 0 1 1. For JK it is 0 1, then XX. So this will be XX and 1 0. Excitation table is drawn. Extended truth table for D flip-flop. So D, and we know that it will be having your Qn, and we know that it will be having the next state Qn plus 1. Present state can be either 0 or 1 for the input 0, and for the input 1 present state can be either 0 or 1. And D is directed. So if the input is 0, next state is also 0. If input is 1, and next state is also 1. So now we have drawn the extended truth table. Now we want to extend this to for the destination. Now we want to extend this to JK. Okay, now I want to extend this to JK. So where my input are 0 and 0, it will be 0x. For 1 0 it is x1. For 0 1 it is 1x, and for 1 1 it is x0. Now both the extension table, extended truth table and excitation table has been drawn. Third thing is you want to draw the K-map for here J as well as K-map for here K. So it is going to depend on a 2 variable function. So we are drawing a 2 variable. Okay, it is going to fall on a 2 variable function. So we are going to draw a 2 variable. So one of the input is D, other input is Qn. This can be either 0 or 1, this can be also either 0 or 1. So now we got the output in 3 locations. Okay, 3 locations, that is 0 1, that is D is 0 and Qn is 1, output will be X. And D is 1, Qn is on the 0, Qn is 0, you'll have your output as 1. D is 1 and Qn is also 1, my output will be X. Okay, so here how we can combine, this can be combined, and this output is nothing but D. So J is nothing but what? We have the output as D. Similarly, if you write for here K, okay, if you write for here K, one of the input is D, another input is Qn, either 0 or 1, this can be also either 0 or 1. Either 0 or 1. So here also if you see, there are 3 things. That is 0 0, my output is X. 0 0, my output is X. For 0 1, my output is 1. For 1 0, my output is X. So this will be grouped like this, which is the output is nothing but what? It is nothing but D bar. Okay, which means that K is nothing but here D bar. K is nothing but here D bar. Now your JK is converted into now D. So how you will convert your JK into D? First draw the block diagram of your JK with a negative edged clock, which will be having 2 outputs. One is Qn, another is here Qn bar. Now J should be connected to D, J should be connected to this thing. Okay, so which means that I am taking an inverter. K should be connected to here D bar, and J should be connected to here D. So if I make this as D, this will be nothing but here D bar. Okay, now I have converted my JK flip-flop to D flip-flop. Okay, so everything is clear for you? Okay, now we will go with the next flip-flop, next conversion of flip-flop. So what is the next conversion of flip-flop? Your JK flip-flop can be also converted into T flip-flop. So here what are the steps? So for the destination flip-flop, I want to draw my extended truth table. Okay, second one, for the source flip-flop we want to draw a excitation table. Okay, excitation table. Third one, same for our source that is J and K. I want to go with here K map reduction. Finally here logic diagram. So first thing is, now the extended truth table for here T flip-flop. Extended truth table for here T flip-flop.
Night வந்திருக்கு.
Extended truth table for here T flip-flop. So I will draw the extended truth table for here T flip-flop. So T Qn, and I am going to with here next state, that is Qn plus 1. So present state may be either 0 or 1 for the input 0, and present state can be either 0 or 1 for the input 1. So here the next state will be like, if the input is on the 0, present state will be retained as such. If the input is 1, the present state will get complemented, that is 0 will turn into 1, 1 will turn into 0. So this is nothing but the truth table, extended truth table for a T flip-flop. Then excitation table for here JK. So how we will draw the excitation table for here JK? Qn plus 1, and what will be my J and K. Okay, so Qn plus 1 can be 0 0 or 0 1 or 1 0 or 1 1. So here it will be 0 1 x x, and this will be something like xx and 1 0. Okay, xx and 1 0. So this will be nothing but the excitation table. So now you extend this to the excitation table. Okay, extend this to the excitation table. So you see where you got 0 0. 0 0 means it is nothing but 0x. Okay, for 1 1 it is nothing but x 0, and for 0 1 it is nothing but 1x, and for 1 0 it is nothing but x1. Okay, for 1 0 it is nothing but x1. Clear? So now excitation table also over, this also over. Using this, now you want to find the K map for what is here J and what is here K. So for the J I am going to draw the K map. So it's going to depend on two variable function. So first I am going to draw a 2 cross 2 matrix, and similarly for here K also it is going to depend on a two variable function. So one of the input is T, another input is Qn. So here also it is T, another it is on the Qn. So this can be either 0 or 1, this can be also either 0 or 1. So this is also 0 and 1, 0 and 1. So where you got your outputs in 3 locations, that is 0 1 is x, that is input is 0 and Q1 is x, this will be x. And another thing is 1 0 it is 1. So 1 0 it is 1. Another thing is 1 1 it is on the x. So you will have a combination like this. When you talk about here, you have the outputs at 3 location, that is 000 will be x, 00 it is on the x, and another thing is 10 it is also x, that is 10 it is also x, and next one is 11 it is on the 1. So it will be also coming like this. So the output, sorry, oh shit, the output, SR flip-flop, where this is gone. Something where it is gone. Somewhere it is gone. Okay, no problem. We will delete that one now itself. That is JK to T alone is missed. JK to T flip flop. So destination flip flop is T flip flop. So we are drawing the T, Qn and Qn plus 1. So okay, so it may be either 0 0 or 1 1. And it can be either 0 1 or 0 1. So if it is on the 0, present state will be retained as such, present state will get complement. So after this it is over. Now we want to write for our JK. So JK, for that we want to know the excitation table for our JK. Excitation table for our JK is 0 0 0 1 1 0 1 1. So this will be nothing but 0 1 x x x x 1 0 x x 1 0 x x 1 0. So for 0 0 condition it is on the 0x. For 1 1 condition it is in the x0. For 0 1 condition it is once again 1x, 1x, and for 1 0 condition it is x1. Okay, x1. So now we are drawing what is for our j and k. So if we draw about our j, so it is 2 cross 2 variable. So t qn can be either 0 or 1. This can be also either 0 or 1. So now we have the output at 3 locations. That is 0 1 is x, 0 1 is x, then 1 0 is 1, 1 0 is 1, then 1 1 is x. So this is the only thing. So where your j is nothing but t, j is nothing but t. And if we talk about here on the k, once again we are expanding this t qn 0 1 0 1. So here I have the output in 3 locations. That is 0 0 is x, then 1 0 is x, 1 0 is x, 1 1 is 1. So here this will be grouped. So you have here k as nothing but, here also your k is nothing but t. Okay, now jk is converted into t. How we will convert into t? It is a simple thing. Okay, I am going to type both the things now. So this will be j, this will be k, and here I am having one clock pulse, and here you will have here present state qn, this will be qn bar. So both the things should be connected with a common input of t. So now jk flip flop is converted into a t flip flop. jk flip flop is converted into a t flip flop. Clear? So what are the things you want to do for the conversions? So first thing is your you will be asked to convert from any one flip flop to another flip flop. Here the source, okay, here the source flip flop is in the that is the source flip flop, that is the any one flip flop. We are saying any one flip flop is here source flip flop, and to convert into another flip flop, okay, convert into another flip flop is the destination flip flop, is the destination flip flop. So what you want to do, first thing is you want to take your destination flip flop extended truth table, first step. Second step is for your source flip flop, okay, for your source flip flop draw the excitation table. Then for the source values, that is either on the J or K source values which can be considered, or will give a source on the inputs. Draw the K map reduction, that is Karnaugh map reduction we want to perform. Okay, finally the draw the final logic diagram. Okay, finally draw the logic diagram for the destination flip-flop. Now we want to draw the logic diagram for the destination flip-flop. The logic diagram for the destination flip-flop. Draw the logic diagram for the destination flip-flop using the source flip-flop. Okay, so if you are clear in all these steps, it will be very easy for us. So in this particular lecture, we have converted all your and the JK to your SR, then we converted into D, then we have converted into T. Okay, so in everything what you want to note down is these are nothing but your destination flip-flops. These are nothing but my destination flip-flops. So what do you want to know? So for all these flip-flops, that is your SR or D or T, you want to know the extended truth table of this. Okay, and this JK is called as here what? A source flip-flops. So for this flip, you want to know about your excitation. You want to know about your excitation table. Okay, so if both the things are known easily, okay, if both the things if you remember very easily, then it is easy for the conversion from your JK to any other type of flip-flop. Okay, so in this lecture we have studied about what is called as what is the excitation table for our JK flip-flop, what will be the extended truth table for our SR flip-flop, extended truth table for our D flip-flop, extended truth table for our T flip-flop, that is toggle flip-flop, delay flip-flop or direct flip-flop. Okay, D flip-flop and set and reset flip-flop, everything we have seen. Moreover, we have also learned about what is called as the JK flip-flop and what is the excitation table for our JK flip-flops. Okay, so in the similar fashion, in the upcoming lecture, we will go with the other type of flip-flop which is called as here D flip-flop. Okay, so D already I told you it is nothing but direct or delay flip-flop. So we will see how to convert your D flip-flop to set reset, that is here SR flip-flop, or how to convert that into a JK flip-flop, or how to convert into a T flip-flop, which is nothing but your toggle flip-flops. Okay, so in the next lecture we will see about this thing. Similarly, in the upcoming lecture we will be seeing about these two flip-flops only, because already in the previous lectures we have discussed about our SR is over. Now in this lecture I have completed our JK, so only the left thing is here D and T. Okay, so this thing should be done. So in the upcoming lecture, first we will see about what is called as this conversion. Okay, and similarly we will see about our T flip-flop conversion. Okay, so how we can convert your T to SR or T to JK or T to D flip-flop. Okay, so every conversion we will see in the upcoming lecture. Okay, so so if any doubt is there in this particular on the conversion, you can ask it. Okay, so all should be very clear in what type of conversion we have seen. So in the last two lectures we have seen about nearly 6 conversions. So totally there are 12 conversions are there. Out of it we have just now seen about 6 conversions, starting from SR to JK, SR to D, SR to T. Then in this lecture we have started and seen your JK to SR, JK to T and JK to T. Okay, so in the upcoming lecture we will see the rest of the conversion. I thank you once again all.